Hello grade 11s and grade 12s. I am back again with a Euclidean geometry question. So today what I'll be doing for you guys is that we will be going through a couple of exam questions of Euclidean geometry. So for the first question, we have this question 4. It says, is the circle... We have a theorem here. I think this is theorem number 3. This one where we have a bow tie. If you haven't watched my previous video, please make sure you do, because I have covered this. I think this is theorem. Yeah, we have theorem 2, theorem 3, and then we have them tangent theorems when it's 6 or 7. So make sure you watch my previous video. I have just my 2 previous videos. I just did these theorems from theorem 1 to theorem 9. So let's go down. There is the question. So firstly, let me read through this question. In the diagram below, points E, F, and G and H lie on the circle. That is point E, that's point F, that is point G, and H lie sorry, on the circle. Then F, H is a diameter. This is a diameter. Remember, we did this when I was doing the theories. So remember that this is a diameter. So we have angles in a semicircle. Whenever we have a diameter here, this is angles in a semicircle. And then DJ is a tangent to the circle at F, this point. A tangent touches the circle once. Cots E, F, and E, G, and E, H, and H, G are drawn. Then we have F1, S58. Now the questions says, write down the sizes of the following angles. So that is the angle is FEH. When you are given something like this, you see it's FEH, which means the angles they are looking for is this one that has a cap on top. That is the angle that they are looking for. Even here, they're looking for angle E, but in this triangle, they're looking for angle F here. So you see, they're looking for E. They said F, E, H. So in this triangle, they're looking for this one. And then they're also looking for F. This F. This is the whole of F. When you see F, H, let's start. It's D. Where is it? D, F, H, this big triangle here. So they are looking for the E. Now this is a diameter, right? So H and F, it's a diameter, but this is only 1 mark. They're only asking for that, and it's 1 mark. So if it was like 2 marks, I would say H and E is a diameter. So E equals to 90 degrees. 90 degrees because why? Angles in a semicircle. If you have an angle in a semicircle, if you have a diameter, the angle opposite that diameter is 90 degrees. Okay, so E equals to 90 degrees. And then, guys, I don't know which question paper is this. I forgot. It's not written on the top, so I am not actually quite sure which is it, but the ones that I know, I will definitely let you know. And then the DF, we're looking for angle F. So here, this F is also 90 degrees. This whole angle here is 90 degrees. Remember, in the theories that I showed you, we did tan cot. that when a radius from here, let's say this is the center or wherever, coming down this this radius here, when it touches the tangent, they form 90 degrees. So when you write that, you're going to say tan cot theorem. Why this 90? This F, it's 90. So we can just say here, when we write, we say A F E H equals to 90 degrees. Why? Angles in a semicircle. And then for B, we will say DFH equals to 90 degrees, and that will be tan cot theorem. Or you can also say tan diameter. A diameter. It's here. So that is the reason that you can say YF equals to 90. Now, the next question for us is to calculate the size of G. Yes, so 4.1.2, we are asked to calculate the size of G. So if you can see that this whole angle here is 90. Do you remember angles in the same segments, right? So if you come from F, go here, you end up at G. So which means F2 equals to G. How do you get to F2? We say 90 minus 58. We'll say 4.1.2 is 90 degrees minus 58 degrees equals to F2. So F2 equals to 32 degrees. Then G equals to 32, and that is angles in the same segment. You remember? Yes. So this one also, you can have a reason for it, because they are equals to 90 degrees. Remember, supplementary angles are equals to 180, and these are perpendicular. They are perpendicular, so you can say that. Now we are going to move to the next question. So we have dealt with this question. We have determined the size of G, which is 32 degrees. You have seen how angles in the same segment work. We start here, we go up, and we end up here. So that is how it works. Now if we were from G, we'll go like G, and then we'll end up at E. So E and H are angles in the same segments, and this G and F are also in the same segment. All right, now we have 3.3. In the diagram, O is the center of the circle. Points A, B, and C and D lie on the circumference. That is point A, B, C, and D lie on the circumference of the circle. And then we have a BOD, which is BOD is a diameter. So A1 equals to 50 degrees, and then B2, this is, B1 equals to 29. A line is drawn from O to F such that the length of BC is 24 centimeters and the radius of the circle centered O is 13. So from O to B is 13. That is the radius. Line drawn from center to the circumference is the radius. But from passing a line passing through the center is a diameter, right? So the first question says determine the size of COD. So they want O. There's a cap on top of O like that. So this is O. And if you remember, guys, that this is a triangle. So this here going this way, again going this down here like this, is that triangle that we get when we say angle at the center is 2 times angle at the circumference, and we are asked to find O. So what we are going to do is that O1 is 2 times, we are asked to say COB. So we are looking for this angle here. So this angle here is 2 times angle at the circumference. So this is how we will write it down. We will say COB equals to 2 times 51, because angles at center, is 2 times angle at circumference. You can write it at its full, but it's not a problem. You can abbreviate your reasons. Now we are here. Determine the size of A2. Where is A2? A2 is here. Remember, this is a diameter. What happens to the opposite angle of a diameter is that this is 90 degrees, right? So this is 90 degrees because angles in a semicircle. So 3.3.2 will say A equals to 90 degrees because angles in a semicircle, right? So A2 plus A1 equals to 90 degrees. A2, this is A2, this is A1 equals to 90 degrees. And then A2 equals to 90 degrees minus 51, which is A1. Then A2 equals to 39 degrees. So we have determined the value of A2. Now we're going to determine the size of D. Here is our D. So don't get confused when you look at this. When you're given a question paper, look at it, guys. Look at it. And it's so important to study your theories, your theorem, to know theorem 1 to 9. Because you'll be able to, and the other additional ones where I did grade 8 to grade 12, I dealt a lot with triangles as well. So let's look. This D is inside this triangle, right? So what is the sum of a triangle? Is 180. I have A. You say in triangle let's say B, D, A in that triangle. So you are going to say D equals to 180. A sum of a triangle is 180. So these three angles should add up to 180 when you add them together. 180 minus, we have the 90 as A plus the 29, and then that is sum of a triangle. And then when you take your calculator and say 180 minus 90 plus 29, you're gonna get a 61. So D equals to 61. So this D is equals to 61. Now the fourth question, determine the length of OF. Remember equation number 1. This is a line drawn from the center. It's a radius, though it's half, it doesn't share the circumference, but it is a radius, and this is a chord, so they form a perpendicular. Now we are looking for that. And if you remember here on additional questions, they say that this length BC is 24. So this line bisects the chord. So this line bisects the chord. That's theorem number 1. So this side and this side are equal. CF is equals to FB because of this thing comes from the center. It bisects the chord. The line drawn from the center to the chord bisects the chord. So this is 24, which means 24 divided by 2. That gives us 12. So FB is 12. We are in this triangle. We are looking for the length of OF. So we will make use of this triangle because we got also that O is there, and a radius of the circle center is 13. It is 13. So really we can even go this side because we know the radius is 13. So from here to here is 13. From here to here is 13. From here to here it's 13. So that is the radius. Go watch that theorem video if you don't understand. Yes, so we're going to use Pythagoras to get this side. So what we will say is OB squared, which is OB is the radius. Remember, we will say R with Pythagoras. We say R squared equals to X squared plus Y squared. Now in this instant, the R squared is the long side, which is the hypotenuse. The OB squared will be equals to the OF squared. The OF is the y-axis, and this one is the y-axis, and this one is the x-axis. So with x and y, you can just interchange them however you like, or you can also start with the FB. It doesn't matter really. So that will be plus FB squared, right? So for OB, we got the radius is 13, hypotenuse is the radius, and then we will have OF squared plus the 12 squared, right? The FB is 12. Now we'll have 13 squared minus 12 squared equals to OF squared. This comes this side, it changed the sign. It was positive, it now becomes negative. Then we say 13 squared minus 12 squared, and then that is 25. We have 25 equals to OF squared. Now we have to get rid of this square root. To get rid of that squared, we square both sides. This will cancel that, and then the square root of 25 is 5 equals to OF, and we have given the value of OF. I hope you understood. All right, here is another question we have here. It's question 3. Now the first question says, you say give reason for your statement and calculation in question 3. So complete the following statement. Opposite angles of a cyclic quadrilateral are supplementary because they're equals to 180. Remember, that's theory number 5. So go back to that video if you still don't understand. It will help you a lot. I think it's my previous video, yes, or 2 videos before, or 2 or 3 videos before this one. And then 3.2, we are given this. Let's write it in the diagram below. O is the center. This is O of the circle. Yes, O is the center of the circle. A, B, and C are points on the circumference of the circle. AB and AC and OC are drawn. So prove the theorem which states that BOC equals to 2 times BOC, this one. There's a cap on top of here, so we're looking for this angle, is 2 times BAC, this one. So what you do, the first thing that you are going to do when you're trying to prove that is that you are going to draw. You will be given an extra answer sheet for this, guys, so you can draw here, but this is compulsory. You must draw lines going down here. Even if you don't draw this one, but this one, it's compulsory. You have to draw it. They'll give you an extra sheet for you to draw. So what we are asked to do is to prove that this angle is 2 times. Now, the first thing that you are going to do is that OA is equals to OB. This is the center, right? This is the circumference. So this is the radius. So they are the same. So we will say OA equals to OB. The reason is radii. That is the radius. The radius are the same. A line drawn from center to the circumference is a radius. So that is radii. And then the second thing that you can do see is that this B equals to A. And then here you must also indicate that this is A1, this is A2. So we will say B equals to A1. And that is isosceles triangle or opposite angles of a triangle. You can say isosceles triangle or opposite sides of a triangle, right? And then now the other thing we can say is that O1, this is O1, this side. O1, because this thing, this B is equals to A1, we can say O1 equals to A1 plus B. And that will be one will represent exterior angle of a triangle. And then this 2, because this is equal to this, and this one will also be that one. And then we can say therefore O equals to 2 times A1, right? So we have proven that. Okay, this will be the last question. I'll probably do the other ones, but in the diagram below, O is the center of the circle. PQRS is a cyclic quadrilateral. prove the theorem that states that P plus R equals to 180. So when you're given something like that, the first thing you can do is we need to find this. So I can draw from this point. I can have that triangle of angle at the center is 2 times angle at the circumference. So you'll be given, whenever you're given an extra sheet, know that you have to draw. So prove the theorem that states that P plus R equals to 180. So the first thing that we are going to do here, you see, this is O1 and this is O2. So we are going to say, because we know angle at the center is 2 times angle at the circumference, we'll say O1 equals to 2P, while angles at center is 2 times angle at circumference. Guys, someone can ask, how do you know that you have to draw? Like if they've given you like a question in your question paper, how do you know where you draw and where you don't draw? You will simply know that by having an extra sheet. If you are given all these questions that I have been showing you, and there's one that has an extra sheet, it means you have to draw. That's how you know that you have to draw. So you have to draw, look and see what you can draw there. Meaning you can only solve that question by drawing. Yes, so the next step, we're proving that angle at the center is 2 times angle at the circumference. You see, when you're just looking at this, you can't prove. You don't know what is this angle. You cannot prove that this angle plus this one equals to 108. So you have to find something to work with. That's why they will tell you to draw, because you're expected to know these theorems. That's why I have a question. You can go back there. So O2 also is angle at the center is equals to 2 times R. So O2 equals to 2 times R, because angle at center is 2 times angle at circumference. The next thing you say is O1 and O2 is a circle, so it has to be 360. O1 plus O2 equals to 360, and then that is revolution, or angles around the circle, or you can say angles around a circle. And then the next thing you're going to do, you know that this is 360, sorry. So which means 2P plus 2R equals to 360 degrees, because this thing is 360. This one is 2 times this one is 2 times this. So this 2 times and this one 2 times equals to this. So they are equals to 360. Now here we have a common factor, which is 2. We have 2 everywhere, so 2 will come outside. P plus R equals to 360 divided by 2 on both sides. Then P plus R equals to 180 degrees. 360 divided by 2 equals to 180. So that is true. P plus R equals to 180, which is what you had to prove. Prove the theorem which states that P plus R equals to 180. Thank you very much for watching, guys. I hope you found this video quite informative. Please share it with your classmates whom you know need this support. Don't forget to subscribe. Don't forget to like, and tell me what you want to see more. And without wasting any more of your time, goodbye and God bless.